Hey Geometry, this is the video for 11.2b. We're going to do the surface area of cylinders. Okay, yesterday was the surface area of prisms, and we looked at LA plus 2b. It's going to be very similar today. So a cylinder is just a prism with circles as the bases. So you're going to have two circles, and then what we'll talk about in a second, we'll have two circles, and this shape here is going to be a rectangle. So what we're going to be adding up today is just that, the two circles and a rectangle. The paragraph here about right cylinders and oblique cylinders you can read through. Right cylinders have a perpendicular height. Oblique cylinders is still a perpendicular height, but the cylinder is a little bit tilted, as you can see in the picture there. So the height might actually fit on the outside of the cylinder. It's really the distance between the circles. That's the way that you got to think about it. So if you're thinking about the lateral area, you can think of a soup can label if you've ever ripped that off, or like the label on your water bottle or something like that, a plastic water bottle. Those have labels, stickers on them, and if you've ever unpeeled those, they are a rectangle. So that's really what you have when you're thinking about the lateral area. The lateral surface area of a cylinder is a rectangle. Surface area is the sum of the lateral area and the two bases. So what you really have when you're looking at a cylinder is two circles and a rectangle. So you can see in this picture here, the middle picture is kind of unrolling the middle, the rectangle part. You can see that the lateral part is just one rectangle with a height here and a base of 2 pi r. The reason that it's a base of 2 pi r is because that's the circumference. This is a soup can label that fits perfectly all the way around the circle. So the top of that rectangle has to be the same as this length, which is the circumference. So that's where the 2 pi r comes from. The circumference of a base is 2 pi r, so that's the base of the rectangle. Okay? The area of the circles, so this one here, okay, if you wanted to get the area of this, you're going to do the base, which is 2 pi r, times the height. Okay? This one has an area of pi r squared. This one has an area of pi r squared. So we have two pi r squareds, and then one 2 pi r times h. Okay, and that's what we'll look at when we develop this formula here next. Okay, lateral and surface areas of a cylinder. So that's exactly what we're looking at here. Okay, the LA, the lateral area, is right here. I'm not going to focus too much on the diameter formula, but 2 pi r times h will give you the rectangle, the label of the soup can, and then this area, or this surface area formula, is including the two circles. So it's still just like yesterday, LA plus 2B, okay? But the LA is going to be the circumference times the height. That's going to give you the soup can rectangle label, plus 2 times the base. The capital B stands for area of the base. That's pi r squared. So this will give you the surface area of a cylinder. So this is the formula that you need for today. Using it is pretty easy. There's only two variables in there. It looks like an ugly, messy formula, but the only things you need are the radius and the height. The height meaning the distance between the circles. So let's try some. What is the surface area of each cylinder? Okay, what we have, 3 is going to be our radius. H is going to be 5, our height, our distance between the circles. All right, so if we want the surface area, it's 2 pi r h plus 2 pi r squared. Okay, well, r is 3 and h is 5. So I'm plugging in 3 for r, 5 for h. Okay, this here is a total of 30 pi plus 3 squared being 9 times 2, 18 pi. So the exact answer for surface area right here is just 48 pi square centimeters. That's our exact answer They didn't tell us that we needed to round or do anything special with that. So I'm just going to go with in terms of pi. Same thing here. H is the distance between the circles. It might not be a vertical height. Okay, it's how far the circles are apart. This is a diameter of 10, which means that we need to know that the radius would be half of that, which is 5. So surface area, 2 times pi times r times h plus 2 times pi times r squared. That's going to be 2 pi times r of 5, h of 12, plus 2 pi r of 5 squared. Okay, so what we have here is 120 pi plus 5 squared is 25 times 2 is 50 pi. This has a total surface area of 170 pi squared, meters this time. If they asked us to get nearest tenth or something, we would just plug the pi in our calculator. I skipped one here before I do that, before we come back to that lunchbox looking one. Okay, this word problem, the radius of a base of a cylinder is 4, and its height is 6. We don't need the picture. Okay, it says what is the surface area? Okay, well the surface area of the cylinder is this formula. 2 pi RH plus 2 pi r squared. So that's 2 times pi times 4 times 6 plus 2 times pi times 4 squared. Okay, there's no picture, but we don't care. So this is going to be 24 times 2, so 48 pi, plus 2 times pi times 16, so 32 pi. 48 and 32, adding up to 80 pi. It says in terms of pi, so that's how I'm going to leave my answer. Square inches, and we're done. Same thing, different problem. H is 9, R is 10, surface area, 2 times pi times r is 10, h is 9, plus 2 times pi times r, which is 10 squared. This is 90 times 2, 180 pi, plus 100 times 2, 200 pi. In terms of pi, adding those together, just add the numbers, leave pi alone. That's 380 pi square centimeters. All right, last problem here. Instead of the paint roller problem that's in your notes, we're going to find the surface area of this toolbox. So what the toolbox entails is a rectangular prism on the bottom and a half of a cylinder on top of it. So we're looking for the surface area, how much metal you would need to make this entire thing. So what we have, and just this is a little bit of a typo, or the picture looked like that was that side wasn't straight, but we're going to assume that it is. So what we have is the surface area of a prism plus this kind of half cylinder. So those are the two things we need to get. If we can get the surface area of the prism and the surface area of the half cylinder, we'd be done. We have to be careful. So if we're looking at this prism first, okay, the prism, there's only 5 sides that are showing, okay, that are on an outside surface. The top of the prism is not a surface, okay, that's kind of the inside of the toolbox. So we need to get like the front and the back, okay, the left and the right, and then the bottom. So we got to get the area of the bottom, okay, which is 14 by 28. That's kind of this piece. Okay, so that's 14 times 28. Okay, then we'll go and find the other ones. I suppose we can get the 14 times 28 first. That's fine. So that's 392. That's how big the bottom is. Okay, we can do like the left / right. Okay, so that's 28 by 17. Okay, we're going to have 2 of those though. So we're going to do 28 times 17 times 2. okay, because there's two of those, the left and the right. So 28 times 17 times 2, that's 952. Okay, and then we need the front slash the back. So the front slash back. Okay, looking at that one, the front slash the back. That's this side, 14 by 17. Okay, this would be like 17 right there. So that's 14 times 17, but there's two of those. So 14 times 17 times 2 is 476. Okay, so total, we're just going to add those up. Okay, 392 plus 952 plus 476, 1,820. So that's the prism part. That's the bottom. Okay. Then we have this half cylinder to deal with. Okay, I'm going to erase all of these markings here. Okay, this half cylinder. Okay, we're just going to take that surface area formula of a cylinder and cut it in half. So what we need is the height of the cylinder, which is the distance between the circles, which is right here, which we know is 28. So h equals 28, r equals, so the radius, they didn't really tell us how far that is. Okay, we know that this is 14, that's the diameter, so that 7 has to be our radius. So we're going to use the cylinder formula, but we got to cut it in half. So we have 1/2 of 2 pi r plus, 2 pi r h plus 2 pi r squared. Okay, half of that. So half of 2 pi r is 7, h is 28, plus 2 pi times 7 squared. Okay, so 1/2 of, so 7 times 28 times 2, that's 392 pi, plus, this is 49 times 2, so 98 pi. I'm going to just need to scroll a little bit to give us some more space. 1/2 of, so 392 plus 98 is 490 pi, and then half of 490 is going to be 245 pi. Okay, that's the half cylinder part. I need to take this number and add them up. So the surface area of the lunchbox. Okay, that's my last step. Surface area of the lunchbox, or toolbox, whatever, is the prism part, plus the cylinder part, the half cylinder part. And we're just going to do this in terms of nearest hundredth, just because I'm going to pick something. 1,820 plus 245 times pi is 2,589.69. So if I wanted to do nearest tenth, this would be 2,589.7. And this is all in square centimeters. So you're going to start to see these shapes getting put together. So that's what we have. Our assignment is on Schoology. So you should have a piece of paper to show your work on and turn in that work after you submit. Thanks for watching. Have a great day.